Hello, fans of geometry. Here's a truss in 2D, pinned at the left. There's a roller at the right, horizontal load at the crown, a downward vertical load here. All the lengths are known, all the positions of the nodes are known, but the question is, what is this bar force? Using the Mueller-Breslau method with no statics whatsoever. So the first step is, as always, going to be to do a perturbation, to stretch out the member along its axis. And I'm calling that perturbed LC. And I am making that really large initially. I think that's super helpful. And I'll show you why I think that's helpful. You can actually see the geometry of everything. Here's my perturbed LC, and it's forced to be along this line here. So that's super important. But this is not the crown. The crown is somewhere else, and the crown is not so trivial to find here because this point is not known. We don't know where this is. It's going to slide along the horizontal. We know that it cannot lift or sink into the ground, lift from or sink into the ground. So the trick is, what I did was I established this fake new point here, and I made it a big red diamond, and I drew my first circle through this radius, which is known, but the radius here is not LC, it's LC plus delta axial, and I made that really large. And then the second circle is centered on this new right point, and its radius is RC. And wherever those two intersect, that's the crown LC. But of course, that crown LC is not established exactly correctly yet because I don't know where this point is. So I have to find where this point is. Okay, so far so good. The next step then is to make two more circles. The first circle is centered on crown LC, and its radius is CD, that vertical member. It's going from the crown to D, and that radius does not change. It's CD. And then the second radius is LD. That's, of course, centered at the left edge. Where those two circles intersect, that's new D. But once again, I don't know where new D exactly is yet because it depends on where I put the right edge. So I'm going to show you the deformed truss, and then I think you'll start to see what's happening here. So here is the new right edge. I'm going to hide the left edge too, the original right edge. I'm going to hide my forces. So now you see what I'm talking about here. So now new D is unequivocally established from the crown and from the left point, but I still don't know where it is. And here's the beautiful thing, I think. You take the last circle, which is the radius of RD, this last circle, and I made it red and big bold, so if you're colorblind, sorry, I'll change that. But I made a big red circle for the last RD, and I know that the right edge must be RD away from new D. So all I have to do is wiggle this point until the big red diamond, I'm going to zoom in here so you see this, the big red diamond intersects the big red circle. Like, how crazy easy is this? Boom, right there. That's the answer. And of course, if you want to be fussy, you know, you could zoom in more and more and more. And then I calculate the energy. This is a positive energy because the horizontal load has a positive X. The downward Z load has a negative energy because the point D is going up, and I add those two together, and I have 481 here, and I get 471 in SAP. But of course I can certainly just keep doing that. It's asymptotically approaching the force in the bar.